This video is going to review piecewise functions. So a piecewise function is a function made up of multiple equations, all defined over specific domains. To evaluate a piecewise function, determine the domain that the input belongs to and use the equation to simplify. When evaluating a piecewise function from a graph, make sure to use the closed circle. So here's one from a graph. We're going to start off with this because graphically is a little bit easier. So remember from evaluating functions that this really means x equals 2. So I'm looking for the output when x equals 2. Notice at x equals 2, there are two circles, an open circle and a closed circle. We always want the closed circle. So f of 2 is 2. F of 3 would be right here. This would be 1. F of 6, once again, I have an open circle and a closed circle. I'm going to use the closed circle, so f of 6 is -1. F of 9 is down here at -2. And then E is a composition. So remember with a composition, we want to work inside out. So I'm going to do this part first. F of 4. So f of 4 is right here. It's going to be 1. Because that's right here on my graph. And then now I need to find f of 1. F of 1 is right here. It's -1. So that means f of 4 is -1. Algebraically. So we talked about different pieces of a piecewise function. These pieces here are known as your domains. And the pieces on the left are your functions. So the first thing you need to do is determine which domain it belongs to. So remember, once again, inside is an x value. So x equals -4. So x equals -4 falls into this domain because -4 is less than or equal to -2. So I'm going to use 2x plus 8 to evaluate, and I'm going to substitute in for x being -4. So remember, you could use a calculator, but this would be done without a calculator. So 2 times -4 is -8. -8 plus 8 is 0. Then I'm going to go to the next one, f of 3. So notice how for here, my domain has a 3 here and here, but I want the one that's equal to. So I am going to use this one because it is equal to 3 here. So I'm going to use x squared minus 3. And I'm going to substitute in 3. 3 squared is 9 minus 3 gives me 6. Now I'm going to move on to my next one, which is f of 5. F of 5 falls in this domain down here because 5 is greater than 3. So I'm going to use radical x plus 3. That means I'm using radical 5 plus 3. So that means that this is just radical 8. If you wanted to simplify, you could. You could write this as 2 radical 2. Then lastly, we have a composition. So remember, composition, I'm working inside out. So f of -2, I'm going to use this part here because that's the equal to. So 2 times -2 plus 8. 2 times -2 is -4. -4 plus 8 is 4. So now I need to find f of 4. So I'm going to go to this part down here. So I have radical x plus 3, which is radical 4 plus 3, which gives me radical 7. And then lastly, and this is where you'll most likely see a piecewise function, to find a rate of change. The figure shows the graph of a piecewise function f for 0 is less than or equal to x, which is less than or equal to 9. What is the average rate of change of f over the closed interval from x equals 2 to x equals 6? So remember, average rate of change is just like slope. So I'm going to use my formula, y2 minus y1 over x2 minus x1. These are my two x values. So that means I need to find their corresponding y values, or essentially I need to find h or f. This should say f. So I need to find f of 2 and f of 6, which we just reviewed earlier in the video. So f of 2 is 1. F of 6, there are 2 pieces. Remember, we're going with a closed circle, so this is 6. And then I'm going to substitute into my formula, 6 minus 1 over 6 minus 2, which gives me 5 over 4. So that is my average rate of change. So that's a quick little recap of piecewise functions to evaluate them graphically and algebraically.